Hey everybody, this is Larry. This is day 7 of the August Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's problem. Hopefully today's problem is a little bit more interesting than yesterday, and hopefully, okay, so this is a hard one, and yeah, we'll see how it goes. Today is West on Wednesday for this week. So I'm a little bit more refreshed. Honestly, I could probably sleep more. I've been really bad about sleep. I just watched that movie Naked Gun though, so definitely support it if you're in a place where that makes sense. I don't know. For me, it's just like a childhood. Like the series is a childhood series, or at least the movie. And then I went back to watch the series because I think it was like in the early '80s, so it's a little bit before my time, even for me. But yeah, I don't know. The movie is good. It's short. It's to the point, and it is I don't know. Just laugh. Anyway, all right. Let's take a look at today's problem. We have 3363. We have a hard problem, so hopefully not too hard because I want to go to sleep. I say that every week or every day, so I don't know. But let's go. 3363. Find the maximum number of fruits collected. There's a game dungeon and by n room. You're given 2D away fruits and by n. Okay. Fruit sub I sub j represents number of fruits in the room ij. Okay. So you have n by a matrix. Ij is the number of fruits. 3 children will play. You have 0, 0, 0, and 1. So top left. Basically, oh yeah. So 3 like this, right? So you have a grid. You have 3 like this. Okay. And you make n minus 1 moves. Okay. I mean, I feel like there is a similar problem on this, right? I don't remember what it was, but I remember getting a wrong answer. But there's a simple problem. I don't remember this one though, ironically, because I've done this one before. But the idea, the one that I'm thinking of is a 2x2, well, I guess not 2x2, but 2D one, which is. I am going to bring up the drawing board to illustrate that one that I'm talking about, and maybe it's very similar, at least very initially. And I'm going to go over this really quickly because it may not be related to this problem. I haven't finished reading it yet. But the idea for that one is that you have... Am I drawing? Oops. Sorry, friends. Am I drawing? All right. You have a grid. The other one is that you have 2 things and you're collecting cherries or apples or something. And then you're trying to go... Both of these people, you're trying to from top to go to bottom. And you're just trying to and you could go one step at a time. Only, I think both of these you can go. You have to go down, but either down. Like for this one, you go either down left, down right, or down straight. For both of these, right? So something like that. So I met and and I think for that problem, actually I don't remember quite, but for that problem, they phrased it as that one happens after the other, but the same thing, which is that if 2 people go to the same room, that thing can only that room can only be collected once, right? So the idea behind that one is that we just want them at the same time, and therefore now for that particular problem, you have I don't know, remember it's n by m or whatever, but let's just call this R for number of row and C for the number of columns. Well, the first person and the second person, they could be in both of any of these C columns. So there's going to be C square states. You can say C choose 2 if you want to be a little bit more precise, but this is big O, right? And times R. And since each of these is constant, I think it's C makes it so that if C is small enough, this will fit, right? Let's go down real quick. I mean, I know that I'm not showing it yet. I just want to look at the N, right? N is 1,000, so I have to think about that, but that's kind of the idea, right? Yeah. Okay. Let's see what this one is about. Okay, n minus 1 move. So the corner person. I don't know what's the best way for me to visualize this is for you at home. I mean, I'm just trying to understand it, and maybe this is blocking me reading the problem, but just have the problem in front of you, another tab or something, and then so you could do. I mean, you don't need to see me read the problem. In any case, so yeah, so you have an n by n grid, right? you have the person from 0, 0. It can go from corner, down, or right. Okay. And then maybe this one, it can go corner to... No, that's a... Did I do this right? Okay, this person is right, but this person is actually just these three. So not, because I was wondering if you have to go left, but no, this one is these three, and this one is always j plus 1, meaning plus 1 in the column. So this one is this one, right? I mean, obviously, the first move it goes out of bounds, but you just won't make that move. Okay. I mean, it sounds like this is the same idea. I think the tricky thing is going to be the number of states, right? The first, but I feel like I don't know if there's any other way of doing it, so this is the way that I'm going to approach it. And I think the key part about this one for me, similar to the first one, or the other one that I talked about, is trying to figure out invariance, right? After one moves, where can people be, right? So this person can only be in like, my square is maybe too big. But, something like that, right? And then this person can only go here, right? Those are the two possibilities. This one can go here, right? Okay, what does 3 moves look like? 3 moves, they have to be one of these 3, one of these 3, right? And then one of these 3. Is that right? Give me a second. I mean, I think the corner person... One, two, I guess this is right. I mean, I'm kind of... To keep it consistent, I guess I should draw that so that you can see 1, 2. I think this is roughly right. I mean, maybe not drawn to scale, etc., right? Okay. And then I think for now, I'm trying to figure out the invariant, right? I think some people also just call it a pattern, but for me, an invariant is more precise, maybe, depending on how we're doing it, because it deals with things that don't change as we, in this particular problem, do the number of moves, right? We know that, for example, for this one, we have at most n moves, right? Because at n moves, then or n minus 1 move, depending on how you want to say it. Like this person would be on the last row. Oh, sorry, last column. But this person will be on the last row, and here this one will be on one of those, I suppose. Right? The 0, 0 person is a little bit awkward, to be honest. Because in 2 moves it can go 1, 2, or it could go down and then 2, right? So it's not, the invariants there are a little bit trickier than I would like. I mean, this is definitely a hard problem. Let me try to think. Oh. Let me double check that I'm doing it right. On the transitions. Let me also get some water. Since this does not look like it'll be a short one, I probably want to hydrate a little bit. Okay. Yeah, I mean, I think the key part to a problem like this is going to be try to figure out the invariance. Can I represent the paths a little bit differently, right? I mean, if it were only these two, I think it'll still be tricky, but doable. Well, let's I think one thing about there is an invariant here, right? First is that, and I don't know if it's useful. Sometimes it may not be. Given that initially we have this quadrant, right? If you divide them into fourths, then actually that's not true. Well, okay. Well, actually, there are a couple of ways to divide this. One is that, for example, for this corner, it can only be reached to this one, right? Oh, wait, I missed it. I missed something. Sorry. Okay. I mean, I was wrong on some things, right? I mean, notice that I even described it incorrectly. I think that's probably why I'm a little bit confused or a lot confused. Okay. The thing is that they all have to end up here. Okay. That is a small miss, but also a huge miss, right? Because then now it restricts the path that things can take. For some reason, I thought that this person can go into the last column, that's what I said, right? But no, you have to be exactly here. And what does that mean? Well, what that means is, and I wish I could just scale this smaller. I don't know if I can actually. I need a better towing on this. Like maybe I need to use Excalibur draw or whatever. Maybe next time. I don't know. Or maybe now. Hang on. Let me see if I can do it. I have too many things on the cache. Okay, fine. Never mind. But all right. Well, we could delete this. It's fine. But what I was going to say is that now we can look at the paths that each of these people take, right? And now it's way more restricted. Note that this corner person, in order to get to here, well, what can it do? There's no choice. You have to choose the diagonal, right? Because if you choose anywhere else, then you just don't get there, right? If you choose anywhere else, like if you go down once, then it just won't. You don't have enough moves because you have to mix. You have to make it exactly n minus one move. Okay, so then now, instead of saying maybe n cubed times n. Now we already reduced one of these to square, right? Because this person doesn't do anything, right? It doesn't do anything in the sense that it has no choice. It just takes the diagonal, right? And then so that's one. And then the other is and without loss of generality, we can think about the other two, right? Well, one is this one. It goes here. As we're drawing it out, but remember that this is the ending point, right? And you could kind of almost work backwards with the ending points as well in a symmetric kind of way, meaning that, okay, you have to end here. That means that one step away from the exit point, it has to be in one of these two, right? Because otherwise, like if you are here, you don't have enough moves to get back to the X, right? I'm drawing stuff on the board like I'm like Hikaru or something on chess, just like, oh, tick. Anyway, but yeah, as you can kind of see where I'm going with, and then, I mean, the lines got a little bit weird, but you get the idea, right? Is that now, and also this is not drawn to scale, because this should be probably either the midpoint or close to the midpoint of the grid, but you get the idea, right? Is that you extend, and then go back, right? So maybe if I drew more scale, then this would be more middle, but yeah, okay, and without loss of generality, you can just flip this, or I guess transpose it to get it from the other one, right? So you could visualize this person going, again, maybe it's not quite drawn to scale, but you get, oops, that's not even right though, even without scale. But you get the idea, right? Something like that. And as a result, there are two things, right? One is, and I don't even know if they overlap. Oh, I guess they will always overlap because of, if you just drew this one like this, then it always overlaps here, right? So there are two, another observation, right, is that the overlap is going to only happen in the middle. Keeping in mind that this person, if it goes below here, it cannot get back. So it will never, it will only go to the diagonal as a possible overlap. But note that you would never go to the diagonal. Why? Because it will never give you anything extra because of the person in the corner, right? The person in the corner will already pick up all the numbers in the diagonal, so we'll never go to the diagonal. So that means that for this person, let me change the color again. For this person, it will never go into this diagonal or this half of the board. And also, not just this half, it would never even go into the diagonal, right? And so that's basically the problem. Then now, yeah. Because then now, if you think of it this way, and the reason why you would never go in the diagonal is because even if you just choose right next to it and dance, you get extra, right? There's no negative, right? Let me double check. I don't think there's any negative. But yeah, from 0 to 1,000. Let me also check that I'm showing on screen because that would be really embarrassing if I didn't. But yeah, so the idea here is that you don't go in the diagonal. You just can't get here, otherwise you don't go back. And yeah, so that means that for this person, you only go basically up to here, right? And similarly, like I said, for this person here, you only go up to here, right? I mean, okay. Like I said, my boxes are terrible. Actually, I think that was the red. So maybe I drew the wrong color. In any case, you get the idea, right? But as a result of that, that means that that this person, this corner, and this person, this corner, they have no overlap. Not even the diagonal. They have no overlap, not including diagonal. And the diagonal, also, you should have no overlap because they have freedom to even choose just the one underneath would be strictly better. Or at least equal. If it's 0, then I guess it's at least equal. But that's basically the idea. Yeah. So then now what does that mean? That means that now we have 3 people. We could get the answer independently for all 3. One of them is, excuse me. Excuse me. One of them, the diagonal person, is basically trivial. The other 2 is I want to say a relatively basic dynamic programming, right? Definitely learn that if you don't know. I mean, we'll go over it a little bit, but that's basically the idea, right? Is that now we're trying to find the max of this area, right? And that area you can figure out dynamic programming. This area we could figure out DP, and the diagonal is just summing it up, and we will have our answer. I think that's it. That's basically the concept. And with that concept, we should be able to solve the problem, hopefully. All right. So yeah, let's go. So okay. So right, we have diagonal is equal to 0 for right, and this part, you know, hopefully is pretty straightforward. So that's diagonal, right? And we want to return, right, plus other stuff, obviously. And then now the other part is DP. We want to go from yeah, so the top going to bottom, and me getting some water. But I would also say, you know, it's a small change about exactly n-1 moves. Reading that or the n-1, n-1 part forces some of the stuff. Otherwise, maybe, I don't know if it's solvable, at least in non-exponential time or something, right? Yeah. So then now we can just write it out, right? N is 1,000, right? Yeah. So I'll just write out the normal DP, right? But why I say it that way is because there is a space optimization version. But I'll keep it simple for today, right? And then yeah, actually I want this to be -infinity so that we cannot start at other places that are not reachable, right? And once you do it this way, then it is even easier, right? And maybe in doing this, there are a lot of things you can do, but maybe I could even write this so that I don't even have to worry about the dp, is that I set it to negative infinity. So that means that it basically constructs a barrier on the diagonal that we had already discussed that you cannot go over. Because if you can't go over for whatever reason, then this barrier would just be silly. Even if you why I say it that way is because I don't want to confuse two concepts, right? One is that the diagonal, I don't want people to think, oh, because we took the fruit, we set it to negative infinity. That is not true, even though the code looks that way. We set it to negative infinity is because of the previous thing that we kind of proved, which said on this person, you would never go all the way to even the diagonal, because it would never make sense. And this is the way to enforce that. Because in another scenario where, you have to prove that they're independent, right? I just want to make that clear. Okay. And then dp is what's it, n-1 is equal to just say fruit sub. I think the one thing that this is awkward about is the n-1 case. So we might have to. Yeah, maybe for that I'll just write this is equal to 0, and maybe that's fine. I don't know. It's a little bit awkward for sure. Okay, so then now this is equal to 0 and -1, right? And if you're more enterprising, you may be able to do it in one, like you could do both pieces together. I'm just gonna write it this way, it's fine, right? And then and you could even maybe, if you really want to, you could abstract this out to a helper function and then call it twice, once for the original graph and then the other one transpose. I don't know how I did it in the past, but I could see myself doing it either. It doesn't really, like, as you see, this is only like 2 for loops. So I don't really worry about it too much, but yeah, right? So then now we want to say dp sub ij is equal to max of dp kind of i-1, j-1, something like this. Yeah. Not quite this because it can go out of bounds, right? But something like this, right, is what we want to do. So we can say, well, plus fruit sub ij. Sorry. Yeah, and I always kind of I've been doing this, and it's only for Leetcode because Leetcode is a little bit silly, and the reason is just because this loop gets happened a million times, and max this is a cheaper max than this max, right? Is the idea. But yeah, is equal to f max. Well, I guess you could say like yeah, whatever. I don't want this fine. I skipped the J on that. Oh no, it's not just on the next line. I was like, huh, not usually that bad, but maybe I am. I don't know. Oops. Something like this, right? And that's it. And then now, I don't know. Naming things is hard, but let's just call this best A maybe for what it sounds like. Just take the max of the last row, right? And now we do it again from n-1, 0. Keep my comments consistent. And this is the same setup, right? I mean, it's gonna be a little bit different, obviously. You're going from left to right instead, but this should be the same idea as before, right? Yeah, actually this as well. It's very easy to make mistakes anyway. And I wrote dx, but I don't even know if I meant dx. Maybe this is just a d for delta, but I don't know. It is what it is. It is confusing the way that I write it. This is from +1, right? So that's -1 on the previous thing. Huh. I actually, no, this part is right. No, this is right. I was like, why am I, yeah, but I'm just being dumb, I think. I -1. No, J -1. Wait, did I mess up? I think I messed up. Dude, no, yeah, this, I messed up. That's why I was confused. Is I -1 on this one? Man, it is very easy to mess up when you're me. This is I -1, okay, and then J plus D. Let's just call it DY to keep it consistent with my usual, or DJ if you want to. Okay, maybe DJ is more specific. Wait, yeah, because this is J plus DJ. DJ, put the music on. Alright. Right. So now this is and then this is always J -1. I don't know how I get like extra smiley faces in here somehow. Okay. Turn that frown upside down, or turn that happy face upside down. Right. Plus fruits of IJ. Also now, oh no, this is still right. It's going down. Okay. But now we have to do best B is you go max of right, something like that. Yeah, last thing. So then yeah. And that should be good. I mean, conceptually should be good. Maybe there's some like silly mistakes in there, which will happen, especially typos, but and silly mistakes. But okay. I mean, there's still some weirdness here for sure. Dong dong dong. 6 means that we're getting 2 for each of these. Did I miss a case? Let's take a look at. No, there's no wrong way to read this, really. That's interesting. I mean, we could just print out DP, I think. Really bad these days. And this one's fine. Oh, I don't know, but it's not fine. But we take a look at this more user. So we start at 1. Oh, I'm just being dumb. I mean, yeah, of course. I don't know why I'm maxing over this. This is just, you have to be at the corner, right? There's no yeah, I don't. I think I'm just confused. I mean, I keep making the same confusion mistake. Like, what's it called? Psyduck. Confused, hurt himself in his confusion. There you go. I mean, a very basic silly mistake somehow. Yeah. And then now maybe YOLO submit. Hopefully we didn't make any silly mistakes. But this is n square, so I don't expect the timing to be timeout, even if it's not super fast. Yeah. 1955-day streak, and that's pretty much it. I mean, I feel like the DP is, like, you should be able to do it, especially for interviews and stuff like this. I think even this problem, you should be able to do it, even if it takes a little bit longer, because there's nothing that requires anything too funky, right? You saw my analysis and breakdown and kind of implemented it. As I said, you can also space optimize this array. I'll leave it for the people at home. Apparently, when I did this on the contest, I got a wrong answer. Oh, I did this. I guess that's fine too, but But I mean, this is probably a better move if there are negatives. But actually, I did it with. I do wonder why this as well. Actually, I mean, this is basically what we're saying, unless I double counted something. But I guess I fixed it. I mean, I did during the contest, so maybe it's just like an off by one somewhere. I bet. In any case, what is complexity, right? It's going to be n squared time and n squared space. This is n squared, this is n squared. Well, this is just O of n, which is linear, right? Because O of n squared, it is, well, the size of the input is n squared, so this is linear in the size of the input. And yeah, that's it. That's all I have for this one. Hopefully it's fun. I always like collecting fruits or strawberries or whatever. So yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. And yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.